All right, so we'll do number 2 altogether. There's several assumptions that you need to make when you're doing this one. So I'll just go through and I'll kind of explain the assumptions you need to be making. So first we have our silver nitrate. And we have copper solid. So that's just Cu solid. So when it's at room temperature by itself, it's just metal. And that doesn't mean it's not in its ion form. Okay? So this will be a single replacement reaction, or now we'll have copper nitrate. Now, how do you know which copper ion to use? You take the first one that is on your periodic table, so open up, and the first one listed is the most common. So then you assume, based on that, unless it tells you otherwise. So what's the most common one, 2 plus or plus? 2 plus. So that's how we know to use it, because it's our most common one. And when you look at your solubility chart, this is aqueous. And then what's left over is silver. Now, it's silver all by itself. So when silver is all by itself, it is a solid at room temperature. So then you have to write silver solid. So this is like that precipitate. You've seen this precipitate. Remember when I had like the copper wire, or the copper like it was just a sheet of metal, and we put it in the silver nitrate, and all that like fuzzy kind of white silvery stuff developed on it. Like it didn't look super pretty, but that was the silver that was precipitating on it. Okay? So now let's write out everything that's aqueous in its ion form. So this is our net this is our, what do I say it? Just ionic equation. What do I call this one? Help me out, guys. Non-net equation. Okay, so now we write out all of our ions. And it is best that if I write them aqueous. It is boring to do that, but it is the best habit. So to make sure you're writing your states in. Oh, I didn't balance it yet. Fail. Okay. So I have Ag, NO3, and Cu. Ag, NO3, and Cu. Okay, so from the left, 1, 1, 1. On the right, I have 1, 2, 1. So I need to put a 2 here. And this comes 2, and so then I put a 2 here. Okay, now it's balanced. So I have 2 silver ions plus 2 nitrate ions plus copper solid makes copper 2 plus aqueous plus 2 NO3 ions plus 2 silver solid. So then we cross out things that are the exact same on both sides. So is my silver the exact same on both sides? No. One is aqueous and one is solid, so I need to leave those. Is the nitrate the same on both sides? Yes. So I can cross off my nitrates. Is my copper the same on both sides? No. This is solid and this is aqueous, so I need to leave those. So now I can rewrite my final net ionic equation as 2 silver ions, aqueous, plus copper solid makes Cu2 plus aqueous plus 2 silver solid. And then you can see at the end that you have everything balanced, so that's good too. So that's the final one for that question.